We'll just do one of each of these. Do that.
Okay. The coordinates of point S is 1, 4.
Yep.
And the grid is in the left-hand corner and up to. So -3 and then up to.
Yeah, and they said put it with a T, and then equation of L.
Is it 3? Is it 3, 0? No, I'm not sure.
If it's going through, so every x coordinate is 3, so 3, 0, 3, 1, 3, 2, 3, 3, 3, 4. This is x equals 3.
Okay.
And because it goes through the y-axis, that's 3 as well.
Okay.
So what would be the equation of this one?
X equals 5.
How about this one?
X equals -4.
And then any idea about this one?
Is that y equals 1?
Yeah. How would you do part B?
So where it's set, so where the coordinate 3 is, you draw a line through it, a straight line through it.
Going across, going up?
Across.
Yeah. So that one is 3, it's fine. How about part B for this one? Do you know that?
Is that along the middle?
Yes, diagonal. So 1, 1, 2, 2, 3, 3. -1, -1. So you can see they're the same for each one.
Okay.
How would you do part D?
So where so draw a line across, no, not across, along 3.
Yeah.
And the x3, yeah.
Yeah, going up. This one?
Is that a diagonal line?
Yeah. That's fine. Okay, how about this one?
Write down the distance from Jane's home to college. 9 kilometers. How long did Jane stop? 11 minutes.
There's only 5 squares between 10 and 20.
Oh wait, how long does Jane stop at the shop? Oh, she stopped at the stop on her way.
So you're almost right.
So she stopped on the way to college. So is that stationary line between the two diagonal lines?
Yeah, but there's only, if there were 10 squares, it would be 11 minutes, but there's only 5 squares.
So it's is it 12 minutes?
So it's 12 minutes, yeah. That's it. How about part A?
How long did Jane stay at her friend's house? How long? So 2 p.m. to, is it 30 minutes?
Yeah.
How far is it from a friend's house to the ice rink? 4 kilometers.
Yeah.
What time did Jane leave the ice rink? 5:30 p.m.
Yeah. So you're gonna be fine for the rest of the years. Well, we'll do this. Yeah, we'll just do A for this one.
Write down the distance from Holly's home to school. 3.
Yeah, and so this time there's 2 graphs, but it's the same idea. Okay, how do we do this?
So you would, to work out how much he pays, you would draw a line from 20 up to the line at best fit.
Yeah.
And then where it meets on the y-axis is your number, so that looks like 16.
Yeah, I think it's 16 pound. This one's gonna be all right. So there's lots and lots and lots of these. How about this one?
So how much is a fixed charge? Is it? I'm not sure. If you need the graph, total. I'm not sure.
The fixed charge is how much, even if you go 0 miles.
Okay. £10.
Yeah. Fine. How would we do part B for this one?
Use the graph to change 25. So where it says 25, which is between 20 and 30, you would use a line of best fit to meet up with you would use a line to meet with a line of best fit.
Yeah.
And then you would move down, and then that looks like it could be 15.
Yeah, it's about that. You just do it with your ruler. Do it as accurately as you can. Change all these. We'll do one of these.
Okay. Are we in C?
Just do all three.
Oh, okay. So A is 23 degrees Celsius.
Yeah.
B is 25 degrees Celsius, and describe the change in temperature from 12 noon. It decreases.
By how much?
So it starts at 25 and ends up at 22. So it decreases by 3 degrees.
Yeah. That's okay. How about this one?
Is it 82?
Yeah. How about this?
Write down the coordinates for point C. 1, 5.
Yeah, and B.
On the grid, mark it across the point D, so that ABC is a rectangle. Is it 3 at 3.7?
Yes. No, not 3.7.
Is it 2.6?
So from B to A is 2 right and 1 up.
Okay. So 2, 1, 2, 1 up. So 3.6.
Yeah. That's it. And so that's gonna make the rectangle. How about this one?
The coordinates.
Just this second part.
Band care 3 corners of a square. So mark it if it's a square. So it's 1, 2, 4, 5, 6. So 2 across. 1, 2, 4 down. So is it at 2, 0?
That would be 3 down.
Sorry.
So you said it'll be 4 down. That's only 3 down.
Oh, so -1.
Yeah. So 2 and then 1, 2, 3, 4. Because that's up at 3.
Yeah.
That's it. How about this one?
On the grid, mark with across the point M, and it's the midpoint. So hold on. 1, 2, 3, 4, 5, 6, is it between it's between the corners 0 and 1, so where the line is. I've just counted up how many lines are in the how many squares are through the line.
Mm-hmm.
I got 6. I went up 3 squares, and that was my midpoint.
So it's 3 across, and yeah, that bit there, that's 3 across from both of them. How about this one?
So C.
Add all of them.
Okay, so A is that a rhombus?
No, rhombus is like a skewed square.
Oh, is it trapezium?
Yeah. How about B?
Draw the line of symmetry of the quadrilateral. Is it 1 down the middle?
Yeah.
Go.
And then you'll be alright for the rest. Okay. How about this one?
P, Q, R are 3 verticals of parallelogram. Right down the corners. So it's from P to Q. It's 3 across and 1 down.
Mm-hmm.
So if we were going from R, it'd be 3 across and 1 up. I think so. 3 minus 2.
I think that's it. Let's see. How about this one? First one.
Right down the coordinates of the midpoint between A and B. 2, 4.
Yeah. Okay. Here's 2.
So, am I right in thinking that a circle has to equal 360?
Yeah.
Okay, so what they've given us is 60 and 140, so you add them together to get 200,
Mm-hmm.
and then that leaves 160 to be the angle, x angle.
60. That's it. How about the one on the left?
Is it 64 as well?
Mm-hmm. Give a reason for your answer.
I'm not sure. I remember it being like, if that's the kind of angle, they're both the same size, same angle.
Yeah, and these are called vertically opposite.
Okay.
So vertically opposite angles are equal. How about the one underneath?
Is that 48 as well?
And give a reason for your answer.
They're vertically opposite.
And what do you know about vertically opposite angles?
They're equal.
Yeah, so you just need to say the whole thing. Top left one.
So if that one is it 40?
No. These are in a straight line.
Oh yeah, straight line's 180. 130.
Yeah, give a reason for your answer.
Because to make a straight line, it needs to equal 180.
Yeah, and so the angles on a straight line add up to 180. How about top right one?
So it's given us a 90-degree angle and a 20 degrees, so that gives us 110. So x is 70 degrees.
And give a reason for your answer.
Angles on a straight line add up to make 180.
Yeah. How about bottom right?
Okay. So is it 85? Is it? Oh, I'm not sure actually. It has to add up to 180, doesn't it? A triangle.
Yeah, but they said the size of the angle A.
Oh, I'm looking at.
Oh, sorry. No, you're right. Yeah. They have to. These also have to add up to 180.
Yeah, I was looking at that one. Wait, are we doing the one on the left or the one on the right now?
No, one on the right. Sorry.
Okay. So the angles are gives us 85. So if you just take that away from 180, it gives us.
Yeah.
Oh no. Yeah. 180. Take away 85 is 95 degrees, and the reason for it is a triangle must equal 180 degrees.
Yeah, angles in a triangle add up to 180. How about bottom left?
So it's given us 60, 25, and 40. So add those all together, that gives you 125, I think. 60 add 25 add 40. Yeah, 125. So then you gotta make sure it's a straight line. So is x 55?
So x is 55. Is that the one they were asking about?
Oh no, it was the size of the angle AOB. So is it? Would you have to add 55 and 40 together?
Well, which angle is AOB? A to O to B.
Oh, 40 degrees.
Yeah. So that's testing that, and you'll see that more. Okay, these two.
The angle is what type of angle is it? Is that a obtuse angle?
Yeah. One on the right.
Acute.
Yeah. Angle Y.
What type of angle? Is it obtuse?
No. Because it's even bigger than 180.
Oh, I'm not sure.
So this is like a person's knee. Doctor hits it and his leg swings around. Reflex.
Okay.
How about this over on the right?
What type of angle is? No, I'm not sure. Or is it acute?
So X is acute, yeah, but that's all right. Okay, how about A on the right?
A on the right. Mark the arrows, the two parallel lines. Is that H and C and A and B?
H to C, A to B. Yeah, that's fine. That's all right. Okay, how about this one?
Write down the mathematical name of this polygon. So this is 10-sided. Is it a decagon?
Yeah. B.
Look at this one. Excuse me. What does interior mean?
The angle on the inside.
Oh, so is it? You just do 144 times 10?
Yes.
1,440.
440. How would you do that top left one?
On the grid centimeters, draw an isosceles triangle. So the two diagonal lines would have to be the same length, and then you connect it with the line below it.
Okay, so I'll just do. That's 4 diagonals. 2, 3. That's 4 diagonals, and then you just connect the base. And top right.
With a perimeter of 10 centimeters. There are so there's the actual the actual grid is 8 centimeters wide. So I'm not sure how to use that perimeter of 10. Oh wait, perimeter's adding them all together.
Mm-hmm.
So is it? So all sides have to be 2.5.
You could do it that way, yeah. So 2.5 each.
Yeah.
So I think technically that'd be a square, but that's fine. Another way to do it would be, what would be the perimeter for half of a rectangle?
5.
And so how could you make a perimeter of 5? Like half a perimeter of 5?
half the perimeter of 5, you would have. Ooh, you would have. Would you have three sides be 1, and then one of the sides be 2?
Yeah, so you could do half of it would be 3 and then 2, and then so the other half would be 3 and 2. So 5 and 5, and that would give you 10 as well.
Yeah.
So yeah, 'cause the other one's, I suppose, kind of a square. Okay, how do we draw a kite?
So with a kite, the two top lines are shorter than the bottom lines, but they all connect in like a diamond shape.
Yeah, so let's say I'll do this one. 2 diagonals at the top, and then just go straight down the middle like that. How about this one on the right?
Draw a rectangle with an area of 12 centimeters. So you could have that'd be a square again. 4 3. 4, 3, 1. You could have the sides 12 centimeters wide, and then the height 1.
So maybe I'll go 12 this way. 1 2 3. No, I've only got 10 squares.
Oh, okay. So maybe have 3 as a height,
Right.
and then 4 along.
Yeah, that'll work. Size of each. Okay, how about top left?
Write down the size of each angle of a square. So you've got. Wait. Write down the size of each. Is it 90 degrees?
Yeah. Let's say this one down here.
Write down the mathematical name of this quadrilateral. Is it a hexagon?
That would be 6 sides.
Oh, is it? Wait, which one is it?
So they all have the same number of sides.
Oh, okay, so. It's a heptagon. Oh no, there's. Oh, is it an octagon? It's an octagon.
Yeah, octagon. Octagon. In the space below, draw a pentagon. How do we do that?
So isn't a pentagon 9 sides?
No.
Oh, pentagon. Why is that? How many? I'm not sure how many sides of the pentagon.
5 sides, like 50p.
Okay, so you could have so you could have. Ooh, I'm not sure. So 1 at the top.
So basically, just do 1, 2, 3, 4, 5. Like any 5-sided shape.
Okay.
That's it. Okay, this one up here.
Shape E is a quadrilateral. Oh, write down the name of this. That a trapezium.
Yeah. How about the one down there?
For polygon G. So it's 6 sides on polygon G, so it's a hexagon.
Yes. Hexagon. left one?
Write down the mathematical name for the 5-side polygon. Is that a pentagon?
Yeah. Bottom right one?
Write down the mathematical name. Is that a rhombus?
That would be a skewed square. This is a skewed rectangle.
Oh, is it parallelogram?
Yeah. That's all right. How about the one down here?
One pattern has exactly one line of symmetry. Is it? Is it A?
Yes. How about the top one?
One of these shapes is exactly 2 lines of symmetry. Right down the layer of the shape. Is it A?
Yeah. And that one down there is gonna be. Okay. How about this one down here?
On the grid, shading 3 more squares so that the completed shape is exactly 1 line of symmetry. So you could shade in the box that is just above the second and top one. So yeah, just there, and then the 2 above it, and then you have a line of symmetry going down.
Yeah. That's it. Okay, how about this on the left?
2 of these polygons are congruent. Write down the letters of these polygons. What does congruent mean?
Identical.
Identical. Okay,
So it might have been slid across, it might have been rotated, but it's the same size, same shape.
okay. Is it A and F? Oh no, because they're not the same size. A and C.
A and C, they have different. One has 8 sides, one has 7.
Oh, is it E and D?
Yes, E and D. Any idea about the one over here?
So I'm probably gonna have to look for the same side. So it looks like D and E are similar.
E is a bit bigger.
Sorry?
I think E is bigger.
I said D and C.
D and C, yeah. So this one. Leave that one. How about this one?
Similar to polygon F. Write down the letter of this polygon. So it's got 1, 2, 3, 4, 5, 6, 7, 8 sides. So it's an octagon.
Okay, and you have to find one that's similar to it.
Oh, I didn't see that. Oh, yeah. So F could be the same as. Ooh. I'm not sure. Is it A?
Yeah, it's A. So it's not congruent because it's bigger. It's similar because it's an enlargement.
Oh, okay.
How about this one?
Could it be A and E?
Let's see, that's 2 and 3. 2, 3, that's 4 and 1, 2, 3, 4, 5, 6. Yeah. So A and A. Okay, how about this? Order of rotational symmetry.
I'm not sure.
Rotational symmetry for B means how many times, if you were to spin it around its center, how many times would it perfectly fit on top of itself?
Once.
Well, these are all 5 sides are the same length.
Oh, okay. So 5 times.
Yeah. How about this one down here?
Write down the order rotation. Is it 2 times?
Yeah. Okay, how do we do this?
So we're reflecting. It'll be on the same on the other side, but flipped. So the closest point is 1 away. So from the mirror line, that point will be also 1 away.
Yeah.
And then the other 2 points are 3 away. So then so that from a line, it's 3 points away, and then you connect them.
Yeah, and then you just do that. TVR for rest. Okay, how about this one on the left?
Draw a line. Line AB's. So could you just draw a line above it? That's the same length.
Yeah, and bottom right.
Oh, sorry.
Bottom right.
Bottom right. That is perpendicular. Oh, give you. I'm not sure. Is it? I know perpendicular is kind of like. Actually, no. I might be thinking of something else. I'm not sure.
It's like a right angle to it.
Okay, so could you just draw a line going up from A?
Yeah, so something like that. Anywhere on that line. So it goes directly through it, not diagonal. Okay, how about this?
Diagram shows an incomplete net of the cube. On the diagram, complete a net for the cube. No, I'm not sure.
So they have to fold to make a cube. So let's say if this is the bottom, so that's the base, then that would be the side. This would fold to be the top.
Okay.
And so you would need one more on this side. So that you cover all 4 sides, and then you've got this one on the top. So a net is like it's going to fold in. Okay, 2 of these are nets of a cube. Which 2?
So if A is the bottom, I think A will go over a few times from the bottom. No, it won't. So I don't think A is. So I don't think A is not.
Yeah, it's not.
Because on the side of A it'd be missing. So what else? So B. I think B could be 1.
Yeah.
C. Over. I don't think so.
No, I don't think so.
D. I'm not. I don't think so as well.
Okay.
So I think E is 1.
So I think the problem here is this diagonal one. When those 2 fold, it kind of goes into itself.
So it's F.
So I think F works. Yeah. Yeah, so sometimes you'll get like 2 things on the top or missing a side and stuff. Any questions there?
No.
Okay. It's B and F, yeah. Okay, how about this one?
The net is folded to make a prism. On the one other point meets with P. Uh, is it the top rectangle?
Yeah. That's up there. Okay, name of each shape.
Okay. So is the top left one a cuboid?
Yeah.
The next one is a prism, triangular prism.
No.
Uh,
That would be if it was the same all the way through. This one goes to a point.
no, I'm not sure about that one.
Egypt.
Okay. Pyramid.
Yeah. This bottom left one.
Bottom left, is that a cylinder?
Yeah. Let's say part A for this one.
Write down the letter of the shape that is a sphere. Is it A?
Yeah. And this one.
Is that a is this a triangular prism?
Yeah, because it's the same all the way through. This one.
No, I'm not sure.
You should know it.
Oh, is it still a triangular? Oh no, it's is it still a pyramid?
Yeah. Pyramid.
Okay.
I think you're okay there. Okay, top left.
So the number of edges. Oh. So the number of edges are 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah. Faces.
The number of faces 1, 2, 3, 4, 5.
And what if they asked for vertices?
Those are the points, so it'll be 6.
Yeah. So vertices would be 6. Okay, you're good. We'll just do, let's see, we'll just do the one down here.
How many faces does shape B have? It has 6 faces.
And D.
How
many edges?
Edges. It has 8 edges.
Yeah. So I think you're good for this stuff. I think you're gonna be good for those. Okay, how about these?
Is that a chord?
Yeah. Keep going.
And then the top right, is that a sector?
Yeah.
And the straight line inside the circle goes. Is that the circumference?
No. Circumference is
the middle. Is it tangent?
So this is the tangent. That's not what they asked for though.
Write down the the straight line. So it's not circumference. What is it? It's not the radius. Is it this? It's not the circumference, is it?
Circumference is this round.
Oh. Diameter.
Correct. Diameter. How would you draw a sector?
So you would just draw a bit of the circle, but shaded in. So maybe just like a triangle or something.
Yeah. So just do 2 radiuses. How about top right?
So with the radius, you have to draw a line to the point. So
Yeah. So like that,
halfway.
center to the circumference.
Yeah.
That's okay. How about this one on the right?
Is it 3?
Yeah. That was 3. How about this one on the right?
Find the area of the shaded shape. So its length is 1, 2, 3, 4, and its height is 2. So is it 4? So is it A, the area?
Well, it's got a bit cut out of it. It would be 4.
Sorry.
It would be 4 by 2, but it's got a bit cut out of it.
Oh, so 4 times 2, that would be 8.
Yeah, but it's missing some squares.
Oh, I'm not sure.
8 minus the 2 missing squares.
Oh, 6.
And so another way to do it is 1, 2, 3, 4, 5, 6. So it's just how many squares are inside the shape.
Okay.
How about perimeter?
Is that just adding all the sides together?
Yeah.
So 1, 3, 7, 9, 10, 11, 12, 14.
1, 2, 3. That's good. That's gonna be fine. It's fine. How'd you do this one?
So would you? So the area of a quadrilateral, that's space times height again, isn't it?
Yeah.
So the base is 3, and the height is 2.
Mm-hmm.
So 3 times 2, that's 6.
Yeah. That one's okay. Okay, let's do this.
Which one?
Both of them. They're kind of connected.
So find the perimeter of the shaded shape. So it's 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Is it 14?
The perimeter, I don't think so. So it's 5, 2. So 5, 9, 10, 11, 12, 13, 14. Yeah, you're correct, are you? Can't be right. 1, 2, 3, 4, 5, 6, 7, 12, 13. It is 14. So how would we do a square with the same area?
So the same area. So the same area of the
sorry, the same area. That's it. Yeah, sorry, go
on. So the same area from this shape is 1, 2, 3, 4, 5, 6, 7, 8. It's so the same. So the same area of that thing is 9.
Yeah.
So what you could do is draw a square where the base and height are 3.
Yeah.
And then just connect them.
2, 3.
Well, with other 3 as well, so it makes a square.
Yeah. I was thinking that it has the same perimeter. Okay, volume.
So is the volume of a prism base times width times length, base times length times width?
Yeah.
So the base is 2.
Yeah.
The width is 2, and the length is 2. So 8.
Yeah. And it looks like there's 8 cubes.
Oh yeah.
How about this?
I'm not sure about. I'm not really good at conversions. Yeah, I'm not sure.
If you were to guess.
Is it 27 liters?
Yeah. So centimeters cubed, 1,000 divided by 1,000. That's all right. Okay, how about this one?
So is it 25 minutes?
Yeah. 25 minutes. Hang on, let's see. Let's do this one. I'm just gonna close this door once, okay. Sorry, how did you get on for this one?
So A, I think is 34 minutes.
Okay, and B.
What time is the latest train from Birmingham International he can catch? And he needs to get there before 11. 10:29.
10:29. He's at Birmingham International. Tile Hill by 11. Is there a later train you can get?
10:39. Oh no, 10:45.
Yeah. 10:45, yeah. So there's 40 for that. I think you're gonna be alright for these. How about this one?
So is the temperature 37.4?
Yeah. So these time ones. How about C for this one?
She needs to get to Stansted Airport before 1 o'clock. She's going to catch a train from Peterborough. Before 1 o'clock, leaving at Peterborough. So the latest train she can get is 11:18.
1 Stansted. 11:18 Peterborough. Yeah. Okay, so you're good there. Yeah. So lots of time stuff. Okay, how about this?
I remember doing bearings, but I remember you need like a protractor, but I can't remember what else.
So you basically, which angle is it that we would measure for this? Do you know?
Is it A?
Yes. So of B from A. So they always write them backwards. Of B from A is from A to B. So tools, protractor. Yeah. So if I make this bigger. Like that. Let me move this over a bit. Okay, so put that on the X, line it up with 0. And so it's always from the north line to the line you're talking about. And so what does it look like?
120. some 120 something degrees.
You're looking at starting from 180. You start from 0?
Oh, 58?
Yeah, it's about
58
58.
to be exact.
Yeah, looks like it's about 58. And do you know how you'd write your answer? If it's a bearing?
58 north.
You write your answer as 0.58 degrees.
Oh, okay.
So it has to have 3 significant figures. So if it was like 100 and something, then it would be fine. Like 158 is fine. But if it's just 58 or just 47, you have to write 0, 100.
Okay.
So that's to remember. Hang on. How about this one? Which bearing did I want us to find?
So you need so from A to B.
Yes. So it's that one again. And this one looks like it's more than 90. It looks like it's more than 100, so it'll be fine. There's no trick there. How would we do this one?
Okay. So from it'd be from A to B. So would you get the protractor and line it up from the thing and see what the angle reaches for B?
Yeah, and I draw a line first.
Okay.
And just so it's that angle there that you'd find. Because this turns clockwise. So how about this one?
So you want it from the tower, so you would draw a line to the church and then use your protractor to find the angle.
Yeah, from the tower. So it's that one. And they're all the same. Which one is it for this one?
One of these triangles is an equilateral triangle. Is it B?
Yeah. And that one's alright. Name of this shit? No, we did it. We fine. 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 Rotational. I think that's probably. Let me just check. Okay. Oh, I think, yeah. So we got almost everything done, but there's a little bit extra that we need to do. Yeah, how was that for you?
Yeah, it was good.
So we basically finished geometry. Just a little thing I'll do, and if you want next time we can do 1 mark data.
Yeah, sure.
Okay, so it's just kind of bringing it all into your memory, just little stuff, you know.
Okay.
Any questions for me in general?
No.
All right. Well done, Noah. You did great. I look forward to chatting again next week.
Same here. Have a good weekend.
All right. Have a nice Easter.